BGP peer group. In this scenario, I'm going to talk about BGP peer group and also another example of usage of internal BGP. In this scenario, we want to talk about two topics. First, BGP peer group, and second, again, internal BGP usage or iBGP usage. Okay, let's go into the scenario. In this scenario, we have 5 AS. 4 of these ASs are the customers. Customer AS 65001, customer AS 65002, AS 65003, and AS 65004. And also we have a service provider, and this service provider should connect these customers together. This is a transit network, and you know that in transit networks we should use BGP as a routing protocol. Let's start the configuration, and in this scenario we will talk about many features. For example, iBGP mesh, for example, next stop self, again peer group, new feature. And after that, after all of this configuration, the connectivity could be achieved between the customers. For the first, I want to show you how we can configure this scenario without peer group. At the first of the scenario, at the start of the configuration of the scenario, I don't use the BGP peer group. Why? Because I want to show you the overhead of administration in this scenario, and after that I want to use BGP peer group and show you how we can use BGP peer group to reduce the overhead of administration. So easy. And in all part of this scenario, I will use from Notepad. I will use Notepad because I want to show you only the result of peer group, and you can do configuration yourself because of this, because the less wasting time, I use Notepad in this scenario. Look at here. In this scenario, we have 5 routers in a service provider with AS 65000 and also 4 routers in 4 customer. Let's start the configuration, and after the initial configuration, we can do the configuration of the peer group and also BGP. Look at here. First, R1. R1's configuration. In this scenario, totally we have 9 routers, okay? Because of that, this is R1, okay? And then R2. I recommend in huge scenarios, in large scenarios, you use Notepad for configuration, okay? R2, and also here, R3, R4, R5, R6, R7, R8, R9. Okay, change the numbers: R1, 2, 3, 4, 5, and then 6, and then 7, and then 8, and finally 9. We should start the initial configuration in R1 here. Look at here in R1. Okay, in R1, en conft hostname R1. Okay, we have 2 interface ETH00, and then IP address here 10.151.255.255.255.0, and then no shutdown. This is the first interface, and we have another interface, Ethernet 01, and the IP address is 10 here 10.161, and then 255.255.255.0, no shutdown. This is the first part of our configuration, and right. Also, we want to use, for example, EIGRP or OSPF inside of the provider. In providers, almost we use OSPF or ISIS, not EIGRP. Because of that, I use OSPF here. I enable OSPF inside of the service provider. Router OSPF, for example, 1, and then I use the router ID router ID quad 1 for R1, and again network. I want to enable an interface ETH00 of R1 OSPF. Network 10.151, 10.151, okay, quad 0, and then area 0, and finally end and write. This is the initial configuration of R1. Let's go to R2. It's almost same as the R1 here, R2. In R2, we should use the host name of R2. The ETH00 is 10.252 and ETH01 is 10.272. It's the IP address of the ETH01. And finally, in OSPF, we should use router ID quad 2 and also network 10.252. 10.252. Let's go to the R3. This is the R3 here, and copy the configuration, initial configuration here. Okay, look at the R3's configuration. ETH00, the IP address of this interface is 10.353, and ETH01 is 10.383. Then configuring OSPF quad 3, and then we should use network 10.353, and because we want to enable OSPF on ETH00 of R3. And finally, the configuration of R4. R1, R2, R3, and R4s are PEs. PE means provider H. Okay, in R4, ETH00 10454, 10454, and ETH01 10494, 10494, and then 4. Okay, router ID is quad 4, and we should use this network command, network 10454. Okay, so easy. And after these routers, we should configure R5. Let's go to R5. This is the R5 host name. Also in R4, we should change the host name, and also in R5 router OSP conf host name R5. Here we have 4 interfaces. Okay, because of that, I copy the interfaces again. ETH00, ETH01, ETH02, and ETH03. Okay, 00 10155, 10155, 01 10255, 10255, 02 10355, 10355, 03 10455, okay, 10455, okay, and fine. And then router OSPF1, router ID is quad 5, and network is in R5 10.155, quad 0, area 0, and also 3 other line 10.255. This is the IP address of the ETH01, 10.355, and 10.455. So easy, 10.455. And now we can configure R6, R7, and also, for example, R8 and R9. Let's to copy of some part of configuration of R5 and going to R6. R6 host name is R6. ETH00 is 10.166 here, and we have another loopback interface loopback 0. The IP address of this interface is quad 6, quad 255. Okay, we don't need no shutdown because loopback interfaces are enabled by default, and also and write. Don't forget, we don't enable on the CE routers R6, R7, R8, R9 the IGP protocol, for example OSPF, with the provider. Okay, hostname R6, ETH00 10166, and then interface loopback 0. Let's go to R7. This is R6 and then R7. Hostname R7, interface ETH00. The IP address of this interface 10.277, and loopback 0 is quad 7. Okay, and again in R8, let's go to R8. This is the R8. This is the R8. In R8, we use hostname R8, and the interface is 10388, 10388, and the loopback